So because calculus was created by two different people at the same time, we have two different notations that happens for derivatives. So we have the notation for derivative of f of x is f prime of x. So this was created by Newton. He was the one who came up with this notation. So sometimes we get a question that says if f of x equals x squared plus 5x, find f prime of x. So this is just a way of asking for the derivative. The other notation that was created by Leibniz stands for the derivative of y with respect to x is dy dx, and it's kind of written in this fraction form. You can say dy over dx, but most people just say dy dx, and it's known that it means a fraction. We're going to do another example. If f of x equals x squared plus 5x, find f prime of x. So we're going to use that definition of a derivative using limits again. So here we go. Remember, the first thing that we always needed to find is we need to find that f of x plus h. So anywhere there's an x here, we're going to put an x plus h. So we're going to have an x plus h squared plus 5 times x plus h. Of course, we're going to simplify this. We're going to expand this out to get x squared plus 2xh plus h squared. Let's move this out of the way. Then we're going to expand the 5 in. So we're going to have plus 5x plus 5h. So kind of take a look. Is there anything we can simplify? Nope, we have no like terms, nothing like that. So that's as far as we can get. So we're going to put this into our definition of a limit. So limit as h approaches 0. I'm just going to write out the basic definition of the derivative. Alright. So now we're going to replace f of x plus h with what we found up here. So we're going to have x squared plus 2xh plus h squared plus 5x plus 5h. Yes, you will find that these get a little bit long, but they all simplify down nicely. And then we want to subtract. So be careful with this. We're going to want to put it in brackets. X squared minus 5x. So we want to be making sure that we're subtracting both of these things. And then we want to divide by h. So now here comes the simplifying process. So the first thing I can see here is I have an x squared and I'm subtracting an x squared. So those two things are going to cancel out. I also have a 5x and I'm subtracting a 5x. So those things are also going to cancel out. So this simplifies us down already. So we have the limit as h approaches 0. So we have 2xh plus h squared plus 5h all over h. So now I can see in the numerator, every one of these terms has an h. So we can actually cancel, just as if we factored out that h, this h with everything that has an h in the top. This only works because everything has an h. So we get the very simplified expression. The limit as h approaches 0 of 2x plus h plus 5. So now I can do my substitution. So I just get 2x plus 5. So this tells me that f prime of x, the derivative, is equal to 2x plus 5. So now I can find the slope of this curve at any point. I just have to replace this x value. On the next slide, you'll find some examples. They work through just the same as this, so try those on your own and see how well you do.